Okay, so we are asked to find a couple different things from an ellipse given the equation. And so I was given the equation of 4x squared minus 4x plus y squared minus 6y is equal to negative 73. Okay, so this is not in standard form, so we have to set it up into standard form. And to do that, we need to group first. Oop, and that's supposed to be 40. My bad. Not 4. Okay, so from here, we're going to factor out our 4. And we're going to have x squared minus 10x plus y squared minus 6y is equal to negative 73. Okay, from here, we have to complete the square. So when we did that, I got negative 25 and 9. We have to add those also to the other side. So instead of negative 73, we're going to do 4 times negative 25. Nope, positive 25. I keep making stupid little mistakes. Okay, so positive 25. So I should have 109 plus 73, and that's going to give me 36. Okay, there we go. Now, from here, we have to find our perfect squares, which are x minus 5 squared plus y minus 3 squared is equal to 36. And then we want to set it equal to 1, so we have to divide everything by 36 in order to set it equal to 1. Okay, so my final equation is going to be, I'm going to write it right here. My final equation is x minus 5 squared plus y minus 3 squared is equal to 1 over 36. That's over 9. Okay, so now we can easily see what our center is. And it is the value of 5, 3. Okay, second thing asked was what our major vertices are. And in order to figure out if we have horizontal values as our majors or vertical values as our major, then we have to figure out what our larger term is. And larger term is always equal to a squared. So 36 is going to be our a squared. And that shows us that our y values are being moved. Or our y values are being moved, which means our x values stay. So we're going to get something kind of like this. We're going to get a vertical ellipse. So to find our majors, we're going to leave our x values because we have changing y values right around here. Okay. And so we know that 36 is equal to a squared. So plus or minus 6 is equal to a, which are these values. So we're going to add 6 to 3, and we're going to get 9. And we're going to subtract it, and we're going to get 3. So those are our major axes on the vertical, vertices, not axes. So those are our major vertices. Now our minor vertices, we are going to be messing with our y value, or our x value. So we are going to have, let me find my paper. We're going to have our y values the same, and we're going to change our x values. So 9 is equal to our b squared, so that means plus or minus 3 is equal to b. Okay, plus or minus 3, that's easy. So 5 plus 3 is 8. 5 minus 3 is 2. So those are our minor vertices. Okay, and then we are asked to find our foci. So to find our foci, we know that we have to find the value of C. And we know that this is our value of A, and this is our value of B, and this is our value of C. So in order to find C, I'm going to go over here. Okay, to find our value of C, we know that A squared is equal to B squared plus C squared. Well, we have A squared and B squared, so A squared is the value of 36. And B squared is the value of 9 plus C squared. 36 minus 9 is 27. So we're going to get 27 is equal to C squared. We're going to take the square root of each side, and the square root of 9 times 3 is equal to the square root of C squared. So we're going to get 3 root 3 is equal to C. So we know that our foci has the same x value as our center. So we're going to leave our center, well, our center is 5, 3. So we know that our x value is going to be 5. And then we are going to have our y value of our center, which is 3. Actually, let me rewrite this over here. It won't erase for me. So I have 5, 3, and then our c value is plus or minus 3 root 3. So we're going to have plus or minus 3 root 3, which is also 5, 3 plus 3 root 3, and 5, 3 minus 3 root 3. So that's our foci values. All right, now I'm going to clear this up a little bit because I have my work kind of everywhere. So number 1 asked our center, which is 5, 3. 2 asked us for our major vertices, which are 5, 9, and 5, negative 3. 3 asked us for our minor vertices, which is 5. Whoops. 3 did not ask us that. I was solving for the foci. 3, sorry, we're going to put this over here. Okay, so I forgot to do... Oh, whoa. Sorry, don't mind me. Okay, so 3 asked us for our minor vertices, not our foci. So 3 is going to be our minor vertices of 8, 3, and 2, 3. And then 4 asked our foci, which is 5, 3 plus 3 root 3, and 5, 3 minus 3 root 3. Okay, sorry if I confused you a little bit there. So center, major vertices, minor vertices, and foci. Last but not least, we have to find our eccentricity, which isn't too difficult. I'm going to do that right there. So our eccentricity is equal to F over A, which is also equal to C over A. So our C value is equal to 3 plus 3 root 3 over our value of A, which is 6. And we know that our E value has to be greater than 0 but less than 1. And if you were to calculate that out, that's about, let me see, 3 plus 3 root 3 divided by 6. That's about 0.74037, which would fit for this. So then, number 5. Our eccentricity is equal to 3 plus 3 root 3 over 6, or you could cancel that and you would get, I take that back. You cannot do this. I just thought about that. It has to be left as 3 plus 3 root 3 over 6. And that's your eccentricity. It can't be simplified any more than it already is.